Lesson 6.1, we're going to look at graphing quadratic functions. A little bit of review about quadratic functions. First of all, the general form of a quadratic function is f of x equals ax squared plus bx plus c. Okay, and a cannot be 0. In other words, you have to have an x squared term. And again, that's when it's in what we call expanded form, meaning non-factored form. Okay. For this lesson, graphing calculator would come in very handy, and showing you how to make tables on a graphing calculator, or we'll review that. So, and the calculator I'm going to show you on is the TI-84. So you probably, you can plug in the values, but it makes things a lot faster if you have a graphing calculator where you can enter functions and get your XY tables. So, alright, so first one we're going to look at is graph f of x equals x squared plus 3x minus 1 by making a table of values. Okay, so if you look at this, alright, and we are going to get into axis of symmetry, y-intercept, and vertex in the next example, but if you make a table of values, let's actually start out on the calculator by doing this, okay? Because we want to kind of know what x values should I pick, and that depends on where the vertex is, and we'll look at that in the next example. But I'm going to pull up the calculator here. So let's go ahead and enter this first example. Reminder that you need to go to y equals. Okay, so if we hit y equals on, this is on 83s or 84s, and we're going to go ahead and enter that function, because f of x is really like y, remember. So we're going to enter x squared, so I hit this button, my squared button, or you can use your power key, plus 3x, that's your x button, and then minus 1. And then let's hit enter. Okay, now to get to your table, okay, notice table's above the graph key here of those 5 on the top. So I'm going to go second, table. Okay, now if you need to change your table setup, you also can go above the window key and change the table setup. But if you notice, and I'm going to scroll up and down here for you, okay, what you kind of want to look for when you do this are these repeat values. You see how you have repeated values here? Here's at negative 4, y is 3. At x equals negative 3, it's negative 1. At negative 2, x value, it's negative 3. At negative 1, it's negative 3. At 0, it's negative 1. And then at 1, it's 3. So do you see how we're starting to repeat? So if I kind of find the middle of these values right here, that's kind of where I want the middle of my table to be. Okay? So I'm going to, in my table here, if we go back to our notes, I'm going to start out at negative 3. Okay? And if I plug negative 3 in, our calculator just gives you, you could go by plugging in negative 3, where you'd have to do negative 3 squared plus 3 times negative 3 minus 1. So if you have a calculator that doesn't do tables and get your f of x or your y values quickly, you're going to have to go by hand and plug each of them in. And there's nothing wrong with that, it's just a little time consuming. So at negative 3, we're at negative 1. At an x value of negative 2, the y or f of x value was at negative 3. At negative 1, we're at negative 3. At 0, we're at negative 1. And at 1, we're at 3. Okay, so there's my table of values. Now, obviously, you could go out further in the negatives or further in the positives with x, but we're going to go there. Let's plot those points. So negative 3, negative 1 will be right there. Negative 2, negative 3, we're right there. Negative 1, negative 3, we're right there. And 0, we're at negative 1. And at 1, we're up here at 3. Okay, which also means I don't have it in my table. At negative 4, we'd also be up at 3. Remember now, quadratic functions will make a parabola, which is a U-shaped graph, which is symmetric. Okay, one half is symmetric to the other half. Okay, or if I fold it in the middle, and there's always a vertex in the middle. Now, if you see here, the vertex is actually somewhere between an x value of negative 1 and negative 2. But we're just doing a rough sketch here, so here's kind of what our graph will look like if we go through and we draw the parabola, and then it's going to go up really fast from there. Make sure you put arrows on each end. So that would be table of values, plotting the points. So make sure you do that on your problems that you're going to be working on in this lesson and show the tables. Don't just do a rough sketch, plot the points. Okay, now we'll look at actually how you find the axis of symmetry, which helps us developing what values we want to put in our table, the y-intercept and the vertex. The axis of symmetry, and I'm going to abbreviate it AOS. Some people call it the line of symmetry, which abbreviation I use is LOS. They mean the same thing. Remember, that is the middle of the parabola. Or it also is the turning point of the parabola, where the parabola turns and goes the other way. Okay. Well, actually, the vertex is the turning point. Okay. The vertex is always on the axis of symmetry or the line of symmetry. Okay. So here's what we have. So what they're asking us to do is find the y-intercept, the equation of the axis of symmetry, and the x-coordinate of the vertex. Okay? Some things I'm going to write down here. The axis of symmetry, kind of a little mini formula. You must write, the line of symmetry for a parabola will always be a vertical line, so it's x equals negative b all over 2a. So you need to know this, or that's how you find the line of symmetry, or the axis of symmetry. I'll use a colon there. X equals the opposite of b over 2a. Okay? The y-intercept, when it's in ax squared plus bx plus c form, is always the c value. Okay? And the x-coordinate of the vertex is always the x value in or the x value in the vertex, okay, which will always be your axis of symmetry value. Okay? It's the same as the axis of symmetry value or line of symmetry value when you do negative b over 2a. Okay, so for this problem, I am going to rewrite my equation in descending order, decreasing order of the exponents. So we really have f of x equals x squared, I'm going to put that first, minus 4x plus 2. We have it now in ax squared plus bx plus c form. In other words, x squared, then x, then your number term. Okay, so if I find let's do the y-intercept first. The y-intercept's the c value. If you notice right here, this is the c value. So the y-intercept is 2 for this one. Okay, the axis of symmetry, we're going to do x equals the opposite of b over 2a. Okay, here's my b value, negative 4. So this says I want the opposite of that. Excuse me. So I want the opposite of negative 4, which means I'm going to take positive 4. So it's x equals positive 4 all over 2 times my a value. A is what's in front of x squared. In that case, that's 1. So I do 2 times 1 on the bottom. So this is x equals 4 divided by 2, or x equals 2. Very key here is when they say an equation of the axis of symmetry, notice it says equation. You cannot just say 2. An equation is going to be an equation of a vertical line. Okay, this would be the equation, and you must have the x equals on there. Okay, so it's x equals 2. That also means the x-coordinate of the vertex is x equals 2 as well. All right, so let's make a table of values. We're going to go ahead and plug this into our calculator. So let's pull the calculator up and plug this in. So I'm going to clear that one out, and we're going to enter x squared minus 4x and plus 2. Okay, and then we're going to get our table. Okay, so now, a couple things. There's our table. You can scroll up and down in that. So as you can see, the repeat values there. Do you see how right here is where we start to get the repeat values? You have that negative 2y value in the middle, or f of x value, but negative 1 on either side of it, then 2, then 7. So what that really means, and remember we found right here that our vertex, okay, or our x-coordinate of our vertex was at 2. That's where I want the middle of my table to be. So I want the x value of 2 there. Okay, this is going to be my vertex. Okay, it's kind of where you want the middle, again, the middle of your table to be. So then I'm going to pick a couple points. With a parabola, you usually need a couple points on either side of your vertex. Okay, so I'm going to pick 0 and 1 on that side of 2, and then 3 and 4. Notice I'm not picking any x values that are negative, and that's because of where my vertex is. Okay, so if you look back on your calculator and go back and fill these in, and when the x is 0, it's 2. When it's 1, it's negative 1. When it's 2, it's negative 2. When it's 3, it's negative 1. And when it's 4, it's 2. Okay, so let's go ahead and plot those points. So 0, comma 2 is right there. 1, negative 1 is right there. 2, negative 2, which is my vertex. That's where parabola turns. At 3, we're at negative 1. And at 4, we're at 2. Okay, and I'm actually going to draw in my equation, or my axis of symmetry. Here's the middle of the parabola, going right through the vertex, and I think it's a good idea when you graph parabolas to draw in that once you find it, and that's what it's symmetrical about. So now you can go ahead and draw your parabola. So it's going to look like that. Again, we want to see points plotted, the tables made, and at least those points that are in your table plotted. Okay, now we're going to move on to maximum and minimum values. Okay, couple things here. How do you determine if the parabola has a maximum or minimum value? A maximum or minimum value would be the highest or lowest point of the graph. Okay, now here's what you need to look at. If a is less than 0, now remember a is the coefficient, or the thing that's in front of the x squared. If that's less than 0, okay, or if it's negative, that tells us that the parabola opens downward. I'm just going to put opens down there. Okay, which means it does this. So it has a maximum value, and I'm just going to put a max there. Okay, so if it's a parabola that's upside down, opens downward, it has a highest point, or a maximum. Okay, if a is bigger than 0, meaning it's positive, so the coefficient on x squared, parabola opens up, and it has a minimum. Okay, so if it's a parabola that opens up, obviously it's got a lowest point, that turning point, so it has a minimum. So you really have to look at the a value, or the coefficient on x squared. Okay, so determine whether it has a max or a min. We're going to go right here, and notice this is f of x equals ax squared plus bx plus c. A is equal to negative 1, so it's negative. That means the parabola opens down even before we graph it. So it has a maximum value. So it has a max, okay, because a is less than 0. Okay? Now, to find the maximum or minimum, you're going to have to go on to the next video.